Good evening, everyone. Welcome to 122nd edition of nasscom FAYA Potiti. FAYA Potiti is a monthly technology session hosted by FAYA in association with nasscom. We aim to create a dynamic platform where tech enthusiasts can come together, discuss and analyze the various trends shaping the IT industry. Through these sessions, we aim to foster tech communities that promote peer learning and knowledge sharing. But before we dive into today's session, let's get started with a quick roundup of the latest updates from the tech world. Please join me in welcoming Chaitanya for the Tech Byte segment.
Thank you, Sri Lakshmi. Good evening, everyone. Let's dive into today's Tech Byte session. So, first is OpenAI's new AI agent operator. I think just like we all want OpenAI's new agent operator is designed to act as an AI agent that directly interact with us to with your computer, and it will be capable of performing different tasks on behalf, making it a potential game changer. So I think we all need it will be very beneficial for us to have a operator that's uh, which can perform with tasks without any supervision. So some of these potentials of this agent is automatic routine task, like it will be able to schedule meetings, sending emails, managing daily to-dos as well. Also, it will be helping in web browsing as well. It is supposed to be launched on coming January 2025. Next is Shop with Pro. I think including myself as well as you, these days there are multiple online products available, and it has become a very difficult situation to like compare these products and shop. So I think Shop with Pro will be helping us in that. It is an a startup Perplexity is launching this Shop with Pro, and this will be helping us to identify products based on photos or prompts, and it will be helping us to compare different products and to select by identifying the most identifies cost effective options as well. So next is Google is bringing Google Bot Gemini app to iPhone users as well. This will be available in Apple Store. So my one standout feature is that it's a real-time voice. It provides a real-time voice chat experience, and this will be available in the background as well, so that even when your phone is locked, you can interact with the Gemini app. It will be becoming like the key highlight is that it is coming to a live competition with the Siri as well. So next is Google DeepMind's Genie 2. So these days it was very interesting when we got the like using AI, when we were able to convert the text into images, right? So using Google's DeepMinds, the image will be able to convert it into 3D environments where we can interact with those environments as well. So we can also convert the real world images into 3D world real images, and it will be able to, we can use the it will be at and advanced applications in games as well as in animated movies.
I am stunned. 2 weeks later, and look at that. Look away, look back. I am stunned. This is one of the most exciting research works I have seen in quite a while. We thought that this was impossible, but scientists at Google DeepMind wrote an AI called Genie that makes a game from scratch, almost. You give it an input image and look at that. You can now play with it. The input can be a drawing or almost anything you want. But all that is nothing compared to what just happened. That was version 1 that only supported these silly little platformer games. But that was just 9 months ago, and now here is Genie version 2. What can this do? Look at that. In goes an image, even a real or made up landscape, and out comes a much more sophisticated game. Wow! Now, we always say that the first law of papers says that research is a process. Do not look at where we are, look at where we will be 2 more papers down the line. And now we are 1 more paper down.
Next is conversational AI with 11 labs. So this is a voice cloning and text to speech API launched to build conversational AI bots. Through 11 Labs is providing a platform where we can the users can customize and build AI text to speech AI bots through which we can interact it to these bots. So we can also personalize different conversations and make AI bots using this platform.
That can speak is now easier than ever.
Hi, what would you like to talk about today?
Introducing conversational AI with 11 Labs. Build, test, and deploy, all in one platform for the most natural way to communicate with technology.
Hey, can I check the status of my order?
Yes, of course. Let me check for you now. Your order is due to arrive at around 2 p.m.
Building conversational AI agents used to be immensely complex and demand huge resources, but not anymore. Start building your agent by creating a voice or exploring our vast high-quality library to discover one that's perfect for your application.
Hello and welcome to DHK Online. How can I help you today?
With a wide range of the best LLMs to choose from, you can then upload your knowledge base and define the goal and personality of your agent. Or alternatively, you can integrate your own server to take full control.
Hi, this is Eric from Bound Events. How can I help?
Hey, I accidentally bought a ticket twice. Could I get a refund, please?
Sure, please read out your reference number and I can begin to process that right now.
Our system will analyze and evaluate your transcripts, providing you with valuable insights, conversation playback, and the ability to test and define success criteria. And it's all possible in 32 different languages.
Welcome to DC Medical. How can I help?
Hello, ¿hablas español?
Sí, por supuesto que hablo español. ¿En qué puedo ayudarle?
And best yet, effortlessly deploy.
So last is this MCP protocol. This is Anthropic is a leading AI model provider which is bringing this protocol through which it connects with different AI assistants to data where we can the developers can connect these AI tools to the database in a secure way so that it won't be affecting their databases. So this protocol connects the main advantage is that it can connect different fragmented data across the database and we can access this data without having any problem, without affecting the databases. So this is about all the tech bytes. Thank you.
Thank you, Chaitanya. Now, without further delay, let's move on to the main session. Today, we are thrilled to welcome Dr. Subbarangaiah, Director and Professor at Veda IIT and an esteemed expert in VLSI Physical Design. Dr. Subbarangaiah will guide us through the intricacies of VLSI technology, unraveling its role in shaping India's journey toward becoming a global semiconductor hub. With his extensive expertise, we will explore fundamental concepts of VLSI design and gain valuable insights into India's thriving chip opportunities. Please join me in welcoming Dr. Subbarangaiah to the stage.
So I'm so happy to have him here because when I met him at Hyderabad, so he actually uh, took me to Veda IIT, which I was very surprised to see, like it is beyond an office space, like just like this. That is, everyone is there studying by doing. Okay, and for the past 27 years, he has been running Veda IIT, and which is actually challenging the existing challenge. The biggest problem that companies face is they cannot find the right VLSI engineers or who are capable of doing things, right? And 100% placement to the students. He picks around 150 people every year, and it is free for the students. And the university gives credits for him for his whatever he students who get admission to his Veda, they do not have to write the final year examinations, and it get transferred. He transfer the credits to the university, and the government, industry, university, everyone working together to ensure that quality resources are being groomed from the college towards industry. And you understand it is for the past 27 years he has been doing it. And I was very surprised to see his thought process because he registered it as a NGO. It is not a business for him. Okay. Third one, students, whoever are capable of doing it, he has a special mechanism to identify the right candidates, and then the companies trust him. That whenever he has picked one candidate, the company sponsor them and then take it there. And then today, that is when he was here, like so the ASAP, Usha Titus ma'am came to know that he is here, so she actually wanted to meet him. So we had a long discussion because Keen somebody is coming here, and today they have a meeting with CM. Raghu. So he already works with them. So they are coming to set up a 20 crore project to set up VLSI Academy in Kerala. Okay. So they actually wanted to meet him. So we just had a discussion, and then well, he was telling like he do not want to train anyone unless there is somebody willing to hire. Because 100% hiring is the reputation of this thing, and he's currently just in Hyderabad and all. Last year on the new batch, he actually opened some tickets to Mulan to have their test and all those things. But I think that is our electronics students and all our people, they just never look about a career in that path because all want to be IT, ITS service companies. They just want to be part of, and that is the culture here. So we do not have a proper direction, and this session is intended to give everyone an idea on what is VLSI, what is happening around the world, why it is being said like it is the future. That very important for us to think about the chip and chip manufacturing or chip designing and those type of things, and where the world is, and as of now, is India in the picture or not, and what is India planning to do, and how actually we can grab this great opportunity, and then what companies have to do, what the students have to be prepared for, and what are the trends in that. So that is what he's going to take us through. So I'm with great honor and respect welcome Subbarangaiah sir. And and then one more thing that I want to add, that is when I met him, he was telling like, okay, he was very happy to know more about Mulan, and he was telling me there is one poem or something, that is he was telling me like if you give food, after some time it will actually get digested. If you give them cloth, after some time it get rusted, and even if you give them building or property also, that is it can go. But if you give them vidya, knowledge, then it is there for the lifetime for the other person, and that is the biggest gift that anybody can give. And that is what MuLearn is doing as well as he's doing. So welcome, sir. Thank you.
At the outset, I wish to thank Deepu for bringing me all the way from Hyderabad to here, and also nasscom for supporting this cause, and also few government officials who met me in the hotel the afternoon and sharing their ideas. To tell you frankly, I visited that International Startup Foundation. Mr. Chaudhary wanted me to come, just I went there. So I happened to meet Deepu there. I never thought that, I can get a good friend like him, because, you meet so many people in conferences, just say hello and then normally they get vanished. But when I heard about MuLearning, he brought one brochure also. So it was so impressive for me, because being a teacher, so I was, though Deepu was telling that I'm doing something, what you are doing here is much greater than what I'm doing. Because to create this type of ecosystem, infrastructure, by involving so many students, so many teachers, so many technocrats, and bringing them to a common cause is definitely a very, very great effort. Unless they see that sincerity in a person like Deepu, people will not come together like that. So I really appreciate Deepu and his team and all of you for running it for how many years you have been doing it? 21. Okay, quite good. So because for your age, you started this. I came to VLSI engineering when I am in my almost 40s or 50s. 97 means now I'm 70 years, 72. So 27. So roughly I say that 40, 45 years around that time I came to VLSI engineering. So at such an young age, you people thought of what is important for society, what you should do beyond, normally people take benefits from society. There are very few people who give back to the society. That is what I felt very good when I was talking to Deepu, because, is fully passionate about what the job that he is doing. So, and probably you are all giving him support. Otherwise, it's not possible. And Jay Shankar and many other people have been associated with him. So, as he said, let me repeat that poem which I mentioned to him. It is in Telugu, but he remembered every word there. అన్నదానము గొప్పదనవచ్చునే గాని అన్నంబు జాములో అరిగిపోవు. Because Telugu words you can't follow. Say giving food to others is considered as the best gift or best thing that you can do in your lifetime. So that's the reason why many people go on contributing money to temples, chowdhuries and all that, so that, people who are hungry, in hunger, who are. So what this sentence says is, no doubt doing this is great, but please remember that in few hours it gets digested. Again, the person needs food. Annadanamu goppadana gani. Goppa means great, but it gets digested in few hours. Vastradhanam okati bhavyadaname gani vastramedadilo chinigipovu. Means if you give clothes, that is also great, but remember, clothes gets, say they get spoiled or they get torn away in 1 year time or 2 years time. Gruhadanam okati bhavyadaname gani kompa konneళ్లలో కూలిపోవు. You can give a house to somebody, but even that can collapse after some time. భూదానము భవ్యదానమే గాని భూమి కొన్నేళ్లలో కూలిపో భూమి అన్యుల పాలగును means the land if you give that also can get transferred to somebody else. అరిగిపోక చిరిగిపోక కూలిపోక అన్యుల పాలుగాక నిత్యమై నిర్మలమై నిశ్చలమై ఒప్పుచుండు విద్యాదానం ఒకటి means without getting spoiled, without getting transferred to others, there is one thing which will remain forever with somebody, that is education, knowledge. If you share knowledge, it gets doubled for you. And somebody who receives it will retain that knowledge forever in his lifetime, and it will protect him. So that's the reason why people, among all the things which you can do in your life, if you want to choose something that will sustain forever, that is knowledge. Knowledge sharing is so great. That is what Deepu mentioned. I'm very happy that he remembered every word, though it was in Telugu, and could convey the meaning better than me. So I was basically a teacher in the college, working in the Department of Physics. Sometime back when, in the year 1997, when GD, who is the founder of Qualcomm Logic, he is in US, he was in US, and the AP government went to Silicon Valley and wanted to bring some entrepreneurs to Andhra Pradesh. So they were all asking the government, okay, we can come to India and AP, but how do we get resources, people? Human resources, knowledgeable resources, skilled resources are extremely important for our companies. So that is going to be an issue. So in that context, government, they discussed with the universities and many people, and finally they came to know that starting a new specialization, developing the labs, offering the courses, and then companies have to come means it will take a lot of time. So it will not work. So they advised him, no, the best thing is that you invite one professor to your company, ask him to develop something, and see that they get trained and they are absorbed. So that is the only way, because everything will be in your hands in that case. So a common friend for me and Mr. GD was there, Mr. J. Chaudhary, who was heading Software Technology Park of India. So he said that I happen to be his teacher. So he said that I will call our teacher, he will help you. That is how I came to this industry, understood what is going on, and then developed the necessary curriculum. Because I was a physics teacher, started Department of Electronics to see that my students get better job opportunities. Because in those days, doing physics, you either have to become a lecturer or you should go for research. So research opportunities are quite less, and becoming lecturer, these posts are also limited. Not so many positions are there in colleges. So many of them are ending up with bank jobs or some entrepreneurial work, some work related to some business, things like that. Many of our classmates were going like that. So then we thought that, I should do something. Either I should understand what is required for industry, because industry doesn't have people, right resources, or I should continue this. That's how I happened to apply some leave for the university and went into the company and saw what is required, and finally the whole thing has happened, this Veda IIT, that concept. Because in those days, many were talking that see, the industry and university are far apart. Everybody thinks great about themselves. Both are in two ivory towers. These people will not go to the college, or not the college people go to the industry. All of them think that they are all great people. So somebody should do something. So then I thought that I can go. Most of my colleagues, because by that time I was a professor, head of the department, I also worked as a director in the university. So many people are advising me, what do you do by going to the industry? So then I told them, no, to learn I'm going. not that I can do something. First, I told Mr. GD that I don't think that I can do something. First, let me come and learn something here. So if it is possible, I will do something. Okay. So that is how I went there, and the whole concept of Veda IIT has come up. So Deepu was asking me, sir, before you go into the what is happening in VLSI industry, why don't you tell something about Veda IIT and then start the remaining part. So this was the last point actually for me, but on his advice. So Veda is actually a unit of Veda Educational Society. So the first condition that I told GD was that if he wants to do Veda for commercial purposes, I am not willing to come, because I'm already there in the university. I'm in a good position. There is nothing that I have to earn or grow further. If at all I have to do, if you are willing to do it on non-commercial basis, means for sustaining Veda IIT you require money, but don't never try to make money out of it. If you make money, it should help again the same institute to grow. So he agreed for that. So he is very magnanimous. So that's how I happen to come here. So today's talk will cover the following points. One, Veda IIT accomplishments, student success stories, an introduction to VLSI, the global scenario, career paths, India's VLSI ecosystem, challenges and solutions, and VLSI, after VLSI, how the new emerging technologies are shaping up, and the interactive session. Any questions? You can also ask me even in between, there is no problem. So we can make it more interactive. See, if I go on talking, I don't think that it will be very interesting. So please stop me. Feel free to ask questions, and then we can progress in that way, so that everybody is participating, and this lecture will be of some use then. So Mr. GD I was referring to is this person actually. So we started in 1997. So Veda IIT offers PG, UG final year, PG means postgraduate, undergraduate final year, finishing school, and corporate programs in industry environment. So that is what it is. So what actually motivated me is this. Say if you take medical profession, you can't think of a medical college without a hospital. Even government won't sanction it. If you want to have a medical college, a hospital should be there. But unfortunately, while we offer engineering courses, we never think of industry. Colleges are different, industry is. So when I was talking to people who studied medicine and all that, they used to tell me, say here most of the things we learn during our house surgeon, or when we go to the hospital, meet the patients, and how the treatment is, when we see the diseases, that is the time when we learn most of the things. So the same concept, Jayshankar, am I right? Okay, I could make it. So we happened to talk in a group call some time back. So he could find some time to come here, very great. So that teaching hospital model I liked very much. So that's the reason why Veda IIT is developed as a teaching company. Means people with working experience should participate in Veda IIT to teach and train the students. And at the same time, students should have opportunity to talk to the industry, have a coffee with them or tea with them, have a lunch with them, and go on discussing what exactly they are doing, what is the project going on, what exactly it requires. So this type of interaction will develop good understanding between students as well as the industry people. So that's the reason why this is developed as a teaching company. Veda IIT is in the midst of group of companies, not separately as a college, right? So this is one thing. Another thing that actually people talk about is, say if you see something, you may forget. If you listen, you forget. If you see, you may remember. But if you do, it becomes your own. That is the proverb from Chinese proverb, right? Says this. Huh? You, 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 you listen, you forget. You see, you remember. You do, you will. It will become your own, right? So this is one aspect. There is also another sloka in Sanskrit. Probably Sanskrit is common for all the states, right? So you can Pataka Patakaschaiva Ye Chanye Sastrachantaka Sarve Vasanine Mudaya. So what does it mean? It means Pataka means people who are students, who study. Patakaschaiva, people who teach. Sastrachantaka means people who do discussions, debates on all our conferences and all these things. And others, ye chanye, those and others, sarve, all these people, vyasanine means vidya vyasanam, means in education, vidyabhyasam, right? Vyasanine, mudaya, murkhulu, means they are all, what do you call murkha? Murkha means they are all ignorant, right? They don't get anything. All these categories. Kriyavan sapandita antar. So the last sentence says that Kriyavan sapandita means what? People who do practically, anubhava purvakanga, anusthana purvakanga, experientialga, people who learn things experientially are those who really get the knowledge. See, even if you take India, in our old Gurukula system or earlier, most of the people are trained in workplace. Say the pot maker's son will become the same or somebody else, no? They are in work, they are seeing how their father is doing. So without learning much, they were doing it. But they didn't get the structured education. But they are skillful. But now what is happening? We are all getting structured education, theoretical education, but practically we are not learning anything. If you take an engineering college today, most of the time they spend in the classroom. Out of 6 hours or per week, I think 6 into 6, 36 hours, they spend 4 hours time only in the laboratory, right? So we felt that if somebody has to become useful to the industry, the practical learning has to be more than, hands-on experience should be more than. So with that in mind, we developed Veda, where for every 1.5 hour theory, there should be minimum 3 hours of lab. So only 2 sessions will be there in a day. And for each class, they will spend double the amount of time in doing the practical work, lab work or assignments. And they have to do there and then itself. So they cannot postpone it. No work is given which can be carried out at the house. So everything they have to complete in the institute itself. So that is how this concept was brought in. So our mission and vision is given here to provide education and professional skills, to develop students with values and character. So it is not enough if you are technically competent. Industry needs people with character. That's why personality interview is also very, very important. So even IEEE says that A professional is one who is technically competent and ethically upright. So both are equally important. So even the companies who are recruiting, they often tell me, if there are two guys who are technically same or technically some edge is there for the other boy, but attitude wise if there is a problem, sir, just ignore the technically competent guy. So they don't mind to sacrifice because they think that technical skills can be given even at later part of time. If there is an attitude problem, he is going to spoil everything in that company. So it is no, they are building the company with hard work, and this guy comes and he goes on spending, wasting time, chit-chatting and talking to others and doing all nonsense. No, the company cannot grow. The entire atmosphere will. So to develop students with values and character, to be a resource center for professionals of global quality, you have to compete globally. It is not enough if you think that locally I am great, I am able to compete better than the other people, because the whole business has become global now. To evolve as an institute, or sorry, to be an incubation and human resource partner for startups. If any startup wants to grow, they can come and work with Veda IIT. There are many companies which have grown in that ecosystem, and that is possible. To evolve as an institute of eminence, imparting experimental learning with industry collaboration. That is our principle. Experimental or experiential learning with industry collaboration. So what we are doing now is offering VLSI engineering domain in some courses in VLSI engineering, embedded systems, and AI I'm not doing much now. I offered some courses earlier. Now it's not in full shape. So this is the ecosystem, Veda's ecosystem. So you can see there are universities, consortium group of companies, and tool partners, because tools are very, very expensive in this particular domain. To design anything, you need expensive tools. So how this ecosystem works is they provide the tools at a concessional rate, Cadence, Siemens, or Synopsys or others, because they know why Veda IIT is doing this. Though I am not a university, whatever concession they are giving to university, they are extending to Veda IIT. And what universities are doing, see, for the programs that I offer, they recognize those programs, they give the degree. So we used to offer this MS program in VLSI engineering. Now I will tell you what are the other programs associated with universities. So these are the universities which have signed MOU with us: Jawaharlal Nehru Technological University, Hyderabad; JNTU, Kakinada; Anurag University, Hyderabad; Vignan University, and even Geetam University, and many more universities are lining up to have MOU with us. So the consortium group of companies today are Softonics, ATI, Ventana. We used to have Invecas also, but Invecas was part of this consortium earlier, but it was recently acquired by a few months back. Yeah, they are partners in the whole system. Okay, so what happened to Invecas is Invecas is acquired by Cadence. Cadence also should understand this and should become a partner. But just because few months back it happened, they are collaborating with us. We have to see how it works, right? So what this ecosystem is doing. So Veda IIT, so what we are doing, industry projects and industry guides are available from the consortium. Performance metrics means what standards should be there in Veda IIT when we are training. Say for example, in Veda, after every module, both lab and theory exams are going to be there. But the standard should be such that questions should not be repeated mostly. You see, what happens in our normal college curriculum is, you know that In this subject, 5 units are there. If I prepare 10 questions, definitely some questions will come. 8 questions or 9 questions they give, I have to answer 5 questions. So here, industry told me very clearly that no choice system. No student can say, if you give choice, what happens? You will leave some chapters, some units, and study some other units, things like that. So no choice. So and the question should be of high standard. And my question paper can be reviewed by anybody in the industry, working professional. They also will contribute something to me, and it should be problem oriented. No question of giving general questions. To the extent possible, we can even make it open book, some of the questions that we give, except for a few. So mostly open book and problem oriented, things like that, and standard questions, no choice. That is how. So they can define the metrics also. Finance, faculty, and referrals also comes from the industry, because Veda IIT doesn't generate money. The entire ecosystem has to take care of the expenses involved. Even when I have a space like this, if somebody is sitting, he knows how much each chair costs, not the real cost of the chair, space, electricity, so many things are there, right? To provide all those things, some finance are required. It's an open system that everybody knows what Veda is spending, so it is covered by that. And then curriculum, design, and labs. While designing the curriculum and labs also, all the people in the industry participate in this. So industry experts convey their, so whether this should be there, need not be there, what is exactly required for the industry. So the whole curriculum is developed based on the requirements which the industry wants, tailored for that. Okay. So then tools and methodologies. So this is coming from, tools are coming from the EDA tool companies. Methodologies, this is another important thing which the colleges are going to face a problem, because you can get tools, but to drive those tools you need expertise. People who have been working with those tools can help in making others understand. Otherwise, you can spend money, you can get licenses, but what to do with that? Tools is one aspect, and tool expertise is another aspect. Just as, suppose I purchase a big helicopter, I don't have a good driver, what happens? So in the same way, you need tools, people who can drive the tools also are required. See, next thing that is required is, if you want to work on designs, you need standard cells. Means when we go deep into that, you will understand. So some library cells are required. You need to purchase those cells also. There, nobody will give you free of cost, right? So you need libraries, you need designs, you need many more things which are required for industry ecosystem. So that is what the industry provides for me. And even while the labs are going on, if I ask the industry to send 1 or 2 people to take care of this new experiment or any such thing, they will send, because that understanding is there. So that ecosystem is developed in that way. So this is all and professional values. So how one should behave, how one should not behave, more than telling, when you are moving with them, you will know it much better. Am I right? So anyhow, people while teaching also, they try to bring in what they should do, they should not do, with reference to even a code writing. Some standards are there. So those things they will. So this is how the whole ecosystem is working. So if you see this, you will understand how people come into Veda IIT, what. So as I told you, on one side university is there and companies are there. Then I take people, engineering graduates, means who completed BTech, and I can offer this 2-year MS program, please come. PG 2-year program, that is MS program in VLSI engineering. See, degree is awarded by university, because the curriculum, everything is approved in the university, in the academic bodies. So they think that, for this purpose, they treat Veda IIT as another college. But in the case of other colleges, they have to follow the university syllabus. But fortunately, what they have given, the freedom that they have given for Veda IIT is, I can develop my own curriculum for Veda MS program, and this they will discuss. If it is as per their norms, they will allow it to happen. But they don't mind even to change those norms. For example, as I told you, according to AICTE, number of lab hours are much less. But here in Veda, 1:2, I told you already, for every theory, double the number of. And Veda works from morning 8:30 to evening 6:30. You have come on that day, 8:30 p.m., even then students are working. So we don't follow. We don't, even the holidays and other things. No vacation, no summer vacation, no winter vacation, nothing. You may wonder, they get half day leave in their MS program also, half day leave per month. That means for entire 1 year, they have to work like that. Then only they can complete. See why they are working like that, how they are getting motivation. Because they know that if they take more and more leaves, and if the training is extended, because they have to complete the training. I tell them that no, I don't mind to conduct it for 3 years also. But who are the losers? They know that they are the losers. They want to complete it as early as possible. So that is how the things are there. So this is for people who have completed engineering. For engineering graduates, I take in 2 ways. One is after completing 3rd year. Before completing 3rd year, they write an entrance test for Veda IIT. If they are successful, universities, all these universities which I have shown, they have entered into an MOU with Veda IIT, and the examinations that I conduct, the marks that I give, they accept them, and this transfer of credits is possible. So that is how that 1 year program works. No, I will send to the university every month the attendance that they have put, and they can also come and visit and see what their people are doing. So that is one aspect. So they get the attendance, they get the marks, and some universities, if they want, they can, for example, JNTU, though question paper setters and other people are industry people, so they take the like question paper from other people. Now they ask the questions from the industry people. Those questions will come as the examination. So that's how they think that though Veda IIT is doing it for their 4th year program, it's not an issue at all, right? So next is yes, it is there. Actually, the entry process is like this. We conduct one preliminary test, that is an online test, so that anybody can take the test from anywhere. So what they do, we don't mind, because but actually it is monitored, and I create a Google Meet for every 10 or 15 students. One Google Meet is there. One invigilator will be there, and he will be supervising and seeing what they are doing. They observe and all that. So we'll try to take all precautions. In spite of it, some people may do some mischief. But what happens is, out of thousands of people who apply, it gives first filter for me. All right. So afterwards they come to Veda IIT. This is a 3 hours test. That test is going to be for 3 hours. Theory test, not theory, I mean to say written test. So in which most of them are problems and related to the subjects that they have studied in the college. Say for example, digital electronics, number systems, combinational logic, sequential logic, C programming, aptitude questions, microprocessors, things like that. Which they have, shall I speed it up? Yeah, okay, right. So like that, we take people from different, so that is while they are in the college, they can join after 1 year, or they can join after 3rd year, or in their 4th year, 2nd semester also they can join. Even polytechnic people can also join. This is how the admissions take place. So in this IRPT program, I said that 1 year program. So important points I have written there. Transfer of 40 or more credits, 4th year 2 semesters they do. Internship and stipend will be there. The students also will get, and no cost to colleges, no fee to students, MOU companies to bear the actual cost. That is how it works.
So I just wanted him to cover this thing because nothing like this exists in the whole world. Nowhere else. That is zero cost to student and zero cost to colleges and 100 percentage hiring for 27 years. And he has been the person behind it. So I just want everyone to listen to that, and then students also here to understand the opportunity out there, and then how they could prepare.
So this is briefly about Veda's accomplishments. Most of the points I have already covered. So we have MOUs with universities and companies to see that the whole ecosystem works. So these are all the programs that we are offering in VLSI. So VLSI consists of digital engineering, analog engineering, and we also require embedded systems because, after the chip is made, the whole software has to work in that. So these people also need a lot of understanding of the digital hardware, AI also. But as I told you, I have run only few batches here. I don't say that we have much expertise here, but still they are working well. So in digital engineering, you have front end, back end. This comes to front end logic design, logic verification, VLSI implementation. That means they do synthesis, they do DFT and other things. Then VLSI physical design, physical verification, standard cell design, analog design, custom layout design, embedded software. So if you have any questions here, you please ask me.
So we can get to that sessions and then
later, right? Okay. So as I told you that this is the teaching industry model, say industry oriented interactive classes and the labs and industry practice. These are the three components. I am not going into details. If you are interested, we'll come to this. So if you see the hiring process, just I have given a small example. I think instead of this, I will show you the next one. So it covered even 2024 also. See, for this IRPT program, Industry Ready Professional Training Program, for 1 year. So first year 1500 people applied, 43 people are taken. Second, 2023, 2000 people applied, 31 people got selected. That means around 2.4%. In this 2024, 2,333 people applied, finally 1.6%. So you can see that how many people get filtered at preliminary, main and all that, and the interview process. Interview process is roughly about 1 day. Every student will undergo at least 1 day interview, different rounds will be there. That is conceptual as well as different concepts we will try to see. See, in all this, what we try to do is his behavior, conduct also we will see, and whether he has a learning capability or not. We don't see how many marks he got. If he doesn't know something, if we give a problem, and if he has questions, we'll tell him that how to solve the problem. Even after giving clues, suppose he is not able to pick up, then we think that it is difficult to train him. So whether he is trainable or not, that is the purpose of the real interview there. So this is about the 6 months program. So even the 6 months program, you see around 6,000 people applied, finally about 84 have come. That means 1.5%. So like that, so there will be 2 such programs minimum, and this will be 1 year program. Sometimes more than that also I may conduct based on the demands of the industry. So this is how the students are spread over different companies. These are all VLSI companies in India and abroad. That is how different students are working in various companies in VLSI field.
So just electronic students, you have to see like which all are the companies that you can actually look for.
Right.
Actually, like ending up in an IT job is not.
So I don't want to cover this also. This is about MS program and how we do it. This is the admission process and all that. So this is how The posters are going to be sent to the colleges. Based on this, they apply online. And so this is for 6 months program, how we recruit. This is briefly about Veda IIT. Okay. You have any questions now? Shall I proceed to the next? Yes, please. See, what is VLSI? How many of you know about VLSI? Great. So I'm not going to make you understand anything because you already know it. So for the remaining people, I try to explain you. It is very large scale integration. Means you have transistors. You put many transistors on a single chip to do a particular task. Say for example, 10 people come together to execute a particular work. Then you can say that that is an integrated group. Am I right? So an integrated group means not one, but it is a team. A team of people are working together to deliver something. Am I right? In a similar way, a lot of transistors are put together on a single chip so that they can execute a particular function. It can be a simple function like NAND gate, NOR gate, OR gate, or a flip-flop, or it can be a complex function like multiplexer, decoder, encoder, or things like that, or it can be much more complex function like arithmetic logic unit or instruction decoder or things like that, or you can have much bigger unit like I squared C or PCI or things like that. No? So you try to bring them together on a single chip and see that they execute that particular functionality. So that's why we call it as very large scale integration, means putting them together to see that they execute a common task. So you find applications in variety of electronic devices, from smartphone to a simple handheld phone to a supercomputer or a satellite. Most of the devices today in all walks of life, you find electronic gadgets, and in these electronic gadgets there are ICs, and those are ICs are designed earlier. They were designed on a PCB with the help of transistors on a PCB. You put them together, solder them, connect resistors, capacitors, and all that. The whole thing has now got integrated into a chip. So that we call it as VLSI chip. So if you see the transistor story, the first transistor, point contact transistor, was invented in the year 1947. 1947, everybody remembers, am I right? Huh? So India's independence and electronics, the first transistor discovery, invention happened in the same year. So that is the first talk. Bradin and Broughton, they are the two scientists who discovered the transistor. So I think William Shockley is another scientist who developed the junction transistor in the year 1948. You understand? So by 1952, there is a hearing aid which is developed with the help of these transistors. They have put together some transistors and made a hearing aid. In 1953, first radio was, small radio was built with few transistors. So first computer, transistorized computer also was built in the same year. 1954, the germanium transistor was, silicon transistor was invented. So this is the first one is germanium. Later, a silicon transistor was discovered, and by 1955, even the cars and other things used to have transistorized radio in the vehicles. And 1958, first satellite was launched. Transistorized satellite was launched because Russia has already launched, so US was lagging behind. So at that time, so America was facing a problem. The total weight of the satellite is much higher. That much weight they could not. So then they found that these transistors came handy. Do you know how much they have paid? $150 per transistor. In that satellite, the first transistors that they have used, $150 in those days. You can imagine. Even now we know the cost. So that is how the first. That is how America proved that it is also on the forefront. So in 1958, not only this, what is the other one? I'm not able to read it. Huh? 59 is this one, that is FET was discovered, invented, 1959. 1965 when Moore's law has come into. You all might have heard of Moore's law. What does it say? For every 2 years, the number of transistors in a chip gets doubled. That means in a given area, if you are putting 10 transistors, now you can put 20 transistors. Next 2 years, 40. Next, so like that. That is what Moore has proposed, and that is continuing. That is what that is how the chip density has increased. So in 1970, the first DRAM was built. Germany people also built, and that was more cost effective than what Americans were doing. So that is where America now got up, we have to do something. In 1971, I may say that this is the first processor, the first 4004 processor. You might have heard 4004, 8080, 8085 processors are there. Most of the students might have been doing experiments on microprocessors. The first small 4-bit processor was built in 1971. 1983, first cell phone was invented, and then next, the later you can say that when 4004 microprocessor was built, the size of the transistor was 10,000 microns. How much? 10,000 microns. So, sorry, not 10,000 nanometers, means 10 microns. 10,000 nanometers. See, if you want to understand how you can appreciate this, the human hair is of 100 microns. Human hair diameter, if you see, is 100 microns, means 0.1 mm. So 10,000 nanometers means 10 microns. So in human hair, in that diameter, you can accommodate 10 transistors. You understand? So the first IC, when it was built, the integration was at the level of 10 transistors in the diameter of a human hair. So again, by 1984, it has come to 1000 nanometers. Means first 1 micron devices have come in 1984. By 2003, it has become 100 microns. 2007, sorry, 100 nanometers. 2007 is 10 nanometers. Now you can imagine how the whole complexity is increasing. So today you are building devices at 2 nanometer technology. So you may ask me, what does this nanometer or the size of the transistor? The size of the transistor is measured as a distance between source and drain. So in a field effect transistor, you have what is known as source, gate and drain. So gate length is considered as a parameter which defines the technology. So when I say that it is 10 nanometers or 2 nanometers, means in human hair, how many transistors can be accommodated? If it is 1 nanometer, let us say, 100, say I told you 100 nanometers, not 100, the human hair is 100 microns, 100 microns. So in 100 microns, say this 2 nanometers. 100 microns means micron means 10 to the power of minus 4. 100 means 10 to the power of minus 4. Minus 6 is micron. 100 microns means 10 to the power of minus 4. So in 10 to the power of minus 4, 1 nanometer means 10 to the power of minus 9. So that means 1 lakh transistors of size 1 nanometer can go into human the diameter of a human, because that is what you can see and feel. What is the diameter of a hair? So in the size of a human hair, they can put how many transistors now? 1 lakh transistors. 2 nanometers means 50,000 transistors will go. So That is how the complexity, the size of the transistor is gradually coming down. Number of transistors that we can put in the chip are also increasing. So parallelly, what is happening? This is the first DRAM, mobile phone. This is a 860 processor, i860 processor. In this, 1 million transistors were there. When first IC was built with hardly 5 to 10 transistors, now when you came to 1989 or 90s, already 1 million transistors have gone into the chip. If you see, for example, today, the number of transistors that go into a chip are in the range of billions and hundreds of billions of transistors. I will show you how the technology changes happen. So now you understand what is happening in VLSI industry. The size of the transistor is coming down. The power consumption of the transistor is coming down. Number of transistors that you can put on a chip, say in the size of a nail, say in this size of a small 1 rupee coin, you can put some billions and billions of transistors. That is how you are able to add lot of functionality. And because of that functionality, you are getting today, for example, you are using a cell phone today, it will come with some functionality, some cost. If you see after 2 years, you will get for the same cost much more functionality and much thinner than the previous one. So this is what is happening. Today, the Moore's law is also failing because the size, when you come to 1 nanometer, it is of atomic dimensions, the size of an atom roughly. So when you reduce the size to such a small size, how to make it function is going to be a big issue. So 10 atoms may be there at 1 nanometer size. So what is going to happen is, along with the Moore's law, people are thinking that this may not get reduced beyond a particular point. So beyond more, system level integration also they are trying to improve. So for example, if you see, the few transistors are here, 200 MOS transistors are there, 2000 cores are there. In each core there are several thousands of transistors. All this is because of copper, low dielectric, silicon germanium, immersion technology, high K dielectric. These are all the changes in the technology, which I don't want to get you bored with those terminologies, but you can understand that. So this way today we are able to reach 50 billion transistors on a chip. How many? 50 billion. Billion means how much? 10 to the power of 9. 10 to the 5 into 10 to the power of 10. 1 billion is 100 crore. 100 crore is 1 billion. Yes or no? So if you see, if it becomes 100 billion, what it will become? 100 billion means 10 to the power of 11. Right? 10 to the power of 11, 100 billion means. So it is reaching almost 50 billion. And see here, what is happening parallelly is, see, this is a new technology called, say one thing is size of the transistor getting reduced, smaller and smaller. Parallelly, what people are doing is chip on wafer on substrate. What is that called? COWOS means what? Chip on wafer on sub. So several dies are put together and built in a single package. So this NVIDIA is today using this technology widely. Say it is one of the top semiconductor companies. They are today trying to increase the complexity of graphic chips by using this COWOS. That means chip on wafer on substrate. This is another thing is called INFO, means integrated fan out. That is another technology people are using for mobile phones, especially Apple and other things, to bring much higher functionality, because this is becoming extremely difficult. So this is growing in one way, and they are trying to put many things together and increase the means try to connect, make connections between the wafers through this technology and bring it. So now the newest one is called SOIC. You might have heard SOC, system on a chip. Means earlier few transistors they were putting together and calling it as integrated circuit. In SOC, what they do is few systems they put on a chip. Means, take for example today's laptop is almost like a supercomputer for several years back, because you are able to put processor, logic, memory, many things into it and see that it functions much better, right? Peripheral chips. So I2C or PCI or so many communications are going to happen. All those are going into a single chip, that we call it as system on a chip. So this is called system on integrated chip, system on IC. Means several ICs are put together in one package. It can be not just two-dimensional, 2.5D, 3D, means vertically wafers are put together, connections are made inside, TSV they call, technology they call, or things, multiple technologies are going to be used, and for your purpose, it looks like a single chip. But inside several wafers can be there. So the limitations of normal technology is overcome. This is called beyond more. This is more according to Moore's law. This is beyond more. So with this, you are able to build such complex chips. So if you want to understand today the complexity, you might have heard your elderly people saying Ramakoti. Is there that practice? Writing the name of Rama 1 crore times will take you to heaven. Huh? That belief is there or not? So those who believe in God, if you write his name 1 crore times, they write a book, and throughout their life they go on writing every day one page, one page, one page. So this chip of 300 billion you have to bring out in less than 6 months or 8 months. How many crores are there in that? 300 billion means 300 into 3 into 10 to the power of 11. 7 crore is 7, means roughly 3 lakh times. So you are writing Ramakoti in 3 lakh times. How many times he has to go to the God? If you call every transistor as a Rama, how much work has to be done? So this is the complexity with which the chip is working. So this is not possible with a single person. So people have to work like a team. So in a big chip, they divide them into various modules, and in each there is again partitioning is going to be done. So block level, full chip level, block level, some partitioning is going to be done. So finally when it comes to you in that, if suppose 200 people or 300 people are working to bring that chip in 6 months, your work will be a small work. But even that you have to do it by understanding the functioning at transistor level. You have to imagine how the whole thing is going to work when you put together those modules. You will put them together. Say for example, don't get confused that this is such a big job. So for example, if I say that in this building, how many sand particles are there? Can you count? Sand particles. So billions and billions are there. If I say that so many billions of sand particles are there, it is extremely difficult to build a building. What they do? They put few sand particles and mud and together and make a brick. So making a building with bricks is much easier than with sand particles. Means you are transitioning from that level to next level. Putting some bricks together and making your modules. Put all the modules together and you make the building very quickly. Same thing is going to happen in the VLSI industry also. What they do is, with the transistors, you design gates. With gates, you design functional blocks. With functional blocks, you design a bigger functional blocks like ALU and other things. With those things, you put them together and make much bigger IPs, intellectual property chips. They are called IPs. They call intellectual property. Means somebody has designed a USB, somebody has designed a PCI, somebody has designed a microprocessor, ARM processor somebody has designed. These are all going to be licensed. So you are not going to purchase at transistor level. Already somebody has designed that. You can purchase a soft block or hard block. So say this block is say already designed, verified, tested and proven on silicon. Such things you will take them, put them. Otherwise, in such a complex chip, even if one thing goes wrong, entire chip spoils, and people have to put several millions and billions of rupees in making those chips. Am I right? So, suppose you make a big film in film industry. What happens if that film fails? Because he has put crores and crores of rupees. The only thing is that he has to go and jump into the ocean. Yes or no? Because there is no way that he can come out of that. In a similar way, even in chip design company, if the chip that you have made is going to fail. So perfection is extremely important. So you cannot take any risk. You can take risk with reference to your life, but not with reference to the life of a chip. You know, so that is how you have to work on it. So the whole thing is developed in that particular way. So now you are able to. You have any questions now at this stage? You understood, I think, to some extent what I mean by VLSI, right? So actually, in the early days, people were calling this under different names: SSI, MSI, LSI, VLSI, ULSI, means small scale integration, medium scale integration, large scale integration, very large scale integration, ultra large scale integration, like that. So in SSI 50 transistors, MSI 500, LSI 2000, 20,000, VLSI is 20,000. Yes or no? So the microprocessor that I have shown is having 20K transistor chips, even small microprocessor. So now ULSI, ultra large scale integration, people are vexed with giving names. So this nomenclature is no longer in vogue. But if you see any textbook, this type of nomenclature is going to be there. Don't worry about it. What you have to understand is everything people call it as VLSI. So you can't go on giving names. So instead of giving names, what is changing here? The size of the transistor is changing. So now people call, instead of in VLSI, generations are there. So first, say for example, I told you 10 microns. The next technology was, according to Moore, number of transistors get doubled in 2 years. After 10, what will come? Area of the transistor becomes half, or in a given area they get doubled. So when area gets half, area is equal to L square. If you say length and width both are same, you call it area is proportional to L square. What is going to happen? L is equal to root of A. Root of A is getting reduced 1 by 2. So that means if you see one technology and next technology, change will be 0.7 times of the length. Means if there is a 10 micron technology, next will be 7 micron, next will be 5 micron. So after 2 generations, the area becomes half. Next generation area becomes half, but length becomes half after 2 generations. Area becomes half for next generation, length becomes half. That's why you have 10 micron, 7 micron, 5 micron, like that. Like that, 100 nanometers. Next, 90, say for example, 90 nanometer is there. 963 means next technology will be 65 nanometers. After 65, 0.7 suppose you say. So 0.7 into 0.7 how much? 0.49. So next technology is 0.5 micron. After 0.5 micron, what will happen? 0.5 into 0.7, 0.35. Yes. So 35 nanometer. Next is 25. 50. After 2 generations, it has to become 25. After 20, like that, you can imagine if whatever technology is going to be there, what is the next technology? 0.7 times the length of the original transistor. Or if you see 2 generations, you can find the next transistor whose length is reduced by half. So like that, now we have moved from 10 microns to 2 nanometers or 1 nanometer. How many times it got reduced, you can imagine, right? So instead of calling with these names, people call everything as VLSI, and they only refer to these new generation they are called technology nodes. So if you are in VLSI field, okay, in which technology you are working. So you don't say that I am working in MSI, LSI or any such thing. You will only say that I am working at 5 nanometers or 2 nanometers or 1 nanometer or 10 nanometers like that. So that is how people understand it. So for every 2 years it is getting changed. So the VLSI engineers also should get equipped to manage those new technologies, new problems associated with it. So applications today, VLSI has a lot of applications in communication, voice, video, data, computers, commercial electronics, digital signal processing, automobiles, medicine, health, military systems, many more. Is there any system, where you don't find electronic item, right? So why it is becoming so important? See, size is getting reduced, cost is getting reduced, speed is increasing, power is getting reduced, and reliability is also increasing, and very high function. If you take a chip cell phone, do you think that any problem is going to come in the chip? Rarely you will find, because that is the type of reliability. So this VLSI technology is growing because the people are accepting this. Okay, so if I go to the next generation one, I will get more functionality at less cost, less power, and everything. That is what is driving this technology. So what is that? Size, cost, speed, power, reliability. These are low cost, higher speed, and lower power. These are reliability is more. So these are the driving factors for VLSI technology to grow so fast, right? So how these chips are going to be made? Please ask me to stop where you think that we are going too much into technical aspects. I'm trying to cover it at very top level. I can say that, at 1 lakh miles away from the ground. You understand? So that is what I am trying to tell. So that, first time I should not bore you with too many things. So this is the VLSI flow. So somebody comes with specifications. I used to have my first student, J. Chaudhary was there. Na? His classmate, Mr. Prasad was there. So he worked with me in university. Later he joined IIT Madras and worked together with IISc professor and all that. Then he went to US. He worked in Apple, actually. So what Apple, the job that they have given for him is they have put him Apple think tank. The first job that they have given for him is to be in Apple think tank. So what is think tank going to do? So his job was to visit colleges, to visit factories, to visit health centers, to visit what they are looking next. Say, suppose they are using laptop. So he will talk to them what next features you are looking for. No? So if student is there that actually, you are using the laptop, what next you want? So you want a Google search, this search, so I'm not able to find this. So like that, so they collect the information and give finally a feedback to the company. If you add these features, this product will become much more, because that is very, very important. Not only technology, more than technology, what product is going to make a success. So that will come from the system specification.
So one thing that I want to add, when he talked about J. Chaudhary, okay. So we have one more person, Bhaskar there. So, and then we have also got a mention about Apple, right? So do you know what powered the first generation Apple iPod? The chip that was developed by Porter Player. And we have people who worked on Porter Player here that went to Apple's iPod. That is Barker is there. And he was the person who actually trained the initial 4 people who also was in Porter Player.
I don't know whether he knows it or not. The first 4 people whom they wanted in Porter Player, Venkat interviewed them from Veda IIT. Venkat Rai Party. So he wanted people, he came from America, and Chaudhary was really struggling to get the people. Then I told them that, you can take Veda IITians. So they belong to 1999 batch. In Veda IIT, 1919 batch students joined. Actually, that is a diploma batch, 3rd batch. First batch was 1997, 98, 99. From the third batch, I have given 4 students to Ms. Chaudhary to start that portal player. And there are people in US who guided them.
And then Portal Player was acquired by NVIDIA in 2007, right? For 357 million. Okay. And then Jay was heading the NVIDIA India, right? And then I think he was the professor of Jay, and he actually took a leave, right,
Yes.
from the college to help him train the
took
students.
an leave.
Yeah.
To come to Hyderabad.
Yeah.
No, he was not
because resources were not available to build chip at that time, and that is how he started. And then he actually came out from that and started with. So I just want to have a mention about that. Yeah.
Pardon.
Graphene-based semiconductors used in that.
Yes, I will show you. Later will come.
Yeah, please continue.
I will add a problems. We will not miss the continuity. So a good question, then we will see. So if you see, everything starts with specification, whether it is software, hardware, starts with specification. From there, people go for architectural design. So that means broadly what are all the blocks that are going to be there, what big functional blocks are going to be there. For example, if it's a microprocessor, what you will do? If you want to design a microprocessor, you know that you have to decide how many bit microprocessor. Is it first one was 4-bit microprocessor, later 8-bit, later 16-bit, 32-bit, 64-bit, like that they were increasing the complexity of the microprocessor. So that's when you increase the number of bits, your processing capacity has gone up. The type of words that you process are going to become more and more. So what are going to be there in the microprocessor? So you are giving some instruction. One instruction decoder should be there. Instructions are to be given in the binary form, but you can't handle binary numbers. So people use octal numbers or hexadecimal numbers to see that, that can be easily remembered by you. So everything finally boils down to binary numbers in this hardware because it is digital. Am I right? So you have to translate everything into those binary numbers. Am I right? So architectural design, what you are going to do? First, you have instructions which are to be executed by the microprocessor. What are those instructions? You can say add, subtract, multiply, or do some such thing. Then how it can do? It needs a hardware which can add. That is what is coming in the ALU, arithmetic logic unit. Arithmetic logic unit, what does it do? It can add, it can subtract, it can multiply, things like that. So many things it can do. So you need to have in your mind how an adder works, how a multiplier works, what type of algorithms you need to use for that. Okay, same thing has to do with different instructions. So it has to remember what instruction is given, what job I have to do. So that means, suppose there are 4 instructions, I can have a 2-bit instruction code. Because 001 code, 01, 10, 11. 4 instructions I can give with 2 bits. If there are 3 bits, 8 instructions I can give. If there are 8 bits, 256 instructions I can give. If there are 16 bits, 64K instructions I can give. Am I right? So you need an instruction decoder which decodes what you have asked in the form of a binary number. Then it translates it into what operand I have to bring from where, what operand I have to take from other place, how I have to add, where I have to put. All these things are required. So that means you need one instruction decoder, one ALU, one memory, where these instructions are put or where this data is put, and how to communicate with all those things that is required. So that is where you call this as a functional design. How to design that processor from a functional point of view. So even when I give some work to a team of people, what they do, who will do what? That is what you are going to decide. So these are all the tasks. So this is done by some X, Y, Z, things like that you have to do. Then for those functions, suppose you say that you need one ALU. How I have to design it with basic gates like NAND gate, NOR gate. Or if I cannot do it at that level, how I can design that ALU with adders, subtractors, etc. Say, what is multiplication? Repetitive addition. What is subtraction? What is division? Repetitive subtraction. So if you know how to design an adder, you know how to get a multiplier. Am I right? So you have to get a say division also. So like that, various functions you can design at adder level or at gate level. So how to design an adder at gate? Every college teaches. So you have one full adder means there are two half adders. In each half adder, what is going to be there? One AND gate or gate will be there. Then that is how you will get the functionality. So you have to design these functions from that level. You understand? So bigger functions, smaller functions. Some can be done with digitally, some can be done analog. Analog means what? Not with zeros and ones. Analog means it is close to the nature. Any value it can take and it can give you output, which is continuous in nature with reference to time. So this design is totally different than this design. So in this design, logic design, a transistor works between cutoff and saturation. Whereas in analog design, it can work continuously, means a change can happen, right? So after this design, then you have what is known as physical design, means all the logic gates which you have put together or functions that you have put, finally you bring them into logic gates, or analog blocks. And those things you have to lay out them, put them in a proper way, interconnect them, and then physically design which gate is going where, which transistor is going where, how they are interconnected. All that is going to happen in physical design. So this is all done on a computer. Finally, you get a code. That code is going to be synthesized. When that is synthesized, how it is going to come into netlist. That means in terms of gates. That gates also you verify whether it is going according to the original specification or not. If it is meeting original functionality, then people go for introduce some testability features like DFT, etc. And from there they send it to physical design. If physical design you are able to put all the things in a proper way, it is like this. You want to build a building. So here you require a bedroom, you require a study room, you require a temple or say God's room or things like that. So you plan everything, proper floor planning, proper placement, proper routing between the devices. All that is going to be done in physical design. And then that has to be verified. Means from the physical design, again you extract back the original circuit and see whether it is meeting the specifications. If all that is happening properly, the stage is correct, then you can send it to fabrication. In fabrication, they are only going to get some drawings, some geometric shapes are going to get. So if you put those geometric shapes one after another, then it becomes a chip. You understand? So there are going to be base layers, metal layers, and all those things. All those things, after physical design, you deliver to the fab, GDS people call it as the file they will give GDS. Layer by layer, they will take, peel it off, and then develop the chip one after another. So that is where fabrication is going to happen. After fabrication, again, OSAT means outsourced assembly and testing. ATMP, assembly, testing, marking, and packaging. So that is how finally chip comes out. So whatever chip that you have made also has to be tested, validated, and then only it can be released into the market. So today, for us, there are so many companies which are into this design. There are many companies who are into logic design. Some companies are into physical design. Some companies are into analog design. For example, your friend, he worked in portal player. So what area you were working, sir? Digital. Audio. So in that there are various blocks. Blocks is trying to design, put them together. It can be either, most probably in this side, front end you might have been working. Am I right? Software means embedded software, right? So after the chip comes, these blocks have to talk together. It needs an operating system. It needs software. So many things, drivers are required. It has to talk to peripheral devices. Many things are there. So that side also people work. So this is one level of design. This is another level of design. This is the third level of design. So then it goes to fabrication. Then this is where we are now spending money. Say, Indian government has spent, proposed to put 10 billion US dollars to support this ecosystem, to bring some fabs. So these fabs can work at what technology? It can work at 10 micron or 1 micron or 100 nanometers or 50 nanometers or things like that. So we are not going to latest technologies. Some old technologies are only we are trying to. So for every 2 years the technology is going to change and people need lot of money for that. So now the government is supporting to bring some fabs at some nodes. You understand? So who will do this physical design, sorry, fabrication as well as assembly testing. So I will show you in the next few slides. So what are all the companies that are approved, how much money government of India is spending, so because of which what is going to happen. So people who work in this area from here to here are called VLSI front-end design and verification engineers. What are they called? VLSI front-end design and verification based on the task. So he can be front-end logic design, front-end analog design, like that, or front-end verification, things like that. So again, physical design. So the people who work here are called VLSI back-end designers in the normal understanding of the companies. So are you working in the front end, or that is what I asked him. Am I right? So front end, back end design or verification. So again, embedded system design. So things like that. Then this is we don't have many engineers in the fabrication side. Here chemical engineers are required, electrical engineers are required, robotic engineers, because the entire fab works with the robots. Am I right? So many engineers are required, not just will. So for the money that the government of India is spending, don't think that they require VLSI engineers. If they are going to design companies, all this knowledge is required, whatever I told you. But otherwise, they can be from other domains also. And we are not providing. Veda doesn't know anything. We know theoretically. We are not doing anything with reference to fabrication. All that Veda is training is physical design and above. Not in this. I can also help to some extent in VOSAT ATMP, but not fully, because we don't have those labs. You understand? So this is how VLSI ecosystem is going to be there. You have any questions here? Please feel free. Don't hesitate, because even if I were to sit on the other side, I will not get immediately questions. But still, better to ask something so that certain things can be clarified. Yeah, I will. See, in any design, if you take a college today, they make you understand the design from a functionality perspective, not from timing perspective. I don't know whether your question is related to that. Let me explain. Huh? Latency, yes, I will tell that. So that only will come now, whatever I am explaining. Say, for example, if I have to go from here to America, I may have to take a flight to Dubai and then to America. Am I right? So a person is going by flight from India to Dubai, Dubai to America, let us say. So functionality aspect I have to say means, I am saying that he has to go to Dubai, from Dubai to US. That is functional. Am I right? Timing means at what time I will get into this flight in India, at what time I will get down in land in Dubai, and what time my next flight is there. Between these two flights, how much time is there? From there to America, how much time? So from there means at every stage, I have to know when I am starting, when I am reaching, when I have to board the other train, and then how I have to reach. Same thing happens in digital design. Means, suppose you take a flop. Flop means a device which can store a value 0 or 1 and transmit that to another flop. There are two flops, right? So this flop is sending data to the other flop. Flop means people call it as flip-flop. There is a device, small gate-like thing, which we call it as a memory, a small memory. So, and it can store the value also. Means if you put in a combinational logic, if you put data, if you remove the power, automatically the data is lost. Or the data will not be stored in that device. In the case of flip-flop, what happens is, whatever data that you have put in that, it will not change unless you write something else in that, you know. So that will be written at a particular instant of time. Until that instant of time you write something new, same data is going to be there. So that device, when it is sending data from this place to this place, some time it takes to travel from this flop to other flop. Yes or no? So that time is divided in multiple ways. From the clock, means the whatever clock that I am sending to transfer the data, at that edge, when I give that, when the data is coming out of that flop, from that flop to other flop, if there is a combination logic, how much time it takes to travel that, and later how much time it is taking to see that the data is stored, right? So for this device, we put some certain timing parameters. Means we call it as clock to queue time. It's data to move from input to output. From output to through a combinational logic, etc., that is called a data path. It takes some time. And again, there is another flop which is receiving it. So when that is receiving, when it is trying to take the data, before that only it should come. Or if I have to give an example, suppose there is a train. Train is leaving Secunderabad station or some station here at 5 o'clock, right? If I have to board the train, I should reach there at least 2 minutes before the 5 o'clock. Then only I can get into the train. Yes. So once I get into the train, to travel to the other place, I require some time. That is called propagation delay. Then if I have to board some other train, then I should know the timing. Before that only I should reach. So like this, data when is moving from one place to the other place, it is not moving instantaneously. There are delays. Those delays are called gate delays or flop delays or wire delays, or there are so many things. Capacitor, RC is there, means some RC delays are also going to be there. So many things are going to be there. I don't want to get into those things. So if you are taking a computer, if you give an instruction, that instruction makes lot of additions are going to be there, lot of subtractions are going to be there. The data is going to be moved from one register to another register, one register to a memory. So all these things take time, right? So with this, in 1 second, how many floating point operations I can do? Using that laptop, how many floating point operations in terms of arithmetic that I have to tell? How many times, how many operations I can do? That decides the throughput of that particular device. Am I right? So if that takes less time, you can do more operations. If that take more time, it can do only less number of operations. So when I'm moving from one generation, one node to another node, what I'm going to do is, my area is coming down, the speed also, since the device is small, it takes less time to transfer that data. Understand? Even logic gates also less. But the connecting wire also is used. The wire becomes thinner and thinner, its resistance will increase. Two resistors coming, two wires coming parallel, it's closer and closer, capacitance increases, or RC times increase. So because of this, delays will increase. So with every change of technology, there are certain advantages, certain disadvantages, because of which the speed can be increasing or decreasing. But the goal is that every new generation you go, speed has to increase. Then only people accept that new generation. Means you have to design that device in that way, or the entire physical design process should happen such that there is a speed advantage, area advantage, power advantage. All these things, if it gives, then only I go to the next node. You understand? So what we are trying to do is, we are trying to optimize in designing these devices, all these parameters, and see that I get maximum amount of speed. So suppose you use germanium and silicon. Silicon has one level of speed, germanium has another level of speed. So based on substance, the mobility of electrons, their speed is going to be different. So from material to material, speeds are going to be. So if I am not able to achieve it with silicon, I will try to achieve it with some other material. That is what the whole problem is, right? So can I move forward? So now you are able to see the entire VLSI flow in very top level and what type of job opportunities. I will show you the entire job opportunities. So in each thing, you know, I am telling you, if you become perfect, you can become either a logic design engineer or logic verification engineer, not the entire chip. In the entire chip, so many engineers are going to be there. You are going to learn only one small thing there. Either you are a designer or a verification engineer can become a designer at a later stage. So some positions you can change at a later stage, but rarely people working in logic design will come to analog. People working in analog, their lifetime, they spend all their lifetime only in logic design or only in analog design. So entire thing you need not know. You have to understand the flow, that's all. So what is my interest field, that I have to learn. So at each stage there are different tools. Architectural design, RTL architect. In logic design, let us say VCS is the tool provided by Synopsys. DC is a tool provided by Synopsys. Prime time is a tool provided by Synopsys. What they will do, they are used for simulation purpose, they are used for synthesis. The code that you have written is finally converted into gates. You use this tool to verify timing. I said that between two flops, you have to analyze the time, which is going to be in nanoseconds and picoseconds. You have to analyze how much setup time is there, how much hold time is there, how much travel time is there. By looking at all those things, between these 1 crore or 1 billion transistors, you have to see whether the timing is properly met or not. So many devices are working. You have to see between every two flops. One flop may contain about 10 transistors. Another flop may contain another 10 transistors. Between these two flops, data is moving and each has its own setup and hold time. Means like every you are moving from one bus to another bus, one vehicle to another vehicle, let us say. You have to ensure that all these timings or protocols are maintained. Even in one place, if you miss it by 10 picoseconds, your chip may fail. Even if you miss by 10 picoseconds, the whole chip may fail at that technology. Unless it is, say for example, at 10 micron technology, picoseconds is nothing. Microseconds are okay. At 100 nanometers, nanoseconds are okay. At 1 nanometer or 2 nanometers, picoseconds, femtoseconds also play an important role. So the analysis that you have to make, the tools have to be very, very effective. They have to analyze the delays very effectively and extract the R values, C values, and the quantum effects. So many things are going to be there. You have to do that. So whatever tool, VCS is Synopsys, NC Verilog is Cadence. DC, this is also, Cerium also is a verification. Genius and DC, you can compare. Prime time and Tempest, you can compare. Like that, there are so many companies. Cadence is one company, Synopsys is another company, Mentor Graphics is another company. Each one gives his own tool. You have to become an expert in using that tool. As I told you, it is not enough if you purchase the tools, but each tool works in a particular way. The instructions that are going to be given to that tool is going to be different, but functionality is going to be more or less same. So you have to learn how to do logic design, how to do verification either with this tool or with these tools. Because if you are working in one company, they may be using Synopsys tools. If you are going to some other company, you may be using some other Cadence tools. So you should have some expertise in all these tools at that stage. That's why in one stage itself to understand all these things, do the job is going to be, it is a lifetime job for him. You understand? So like that is going to be there. So in analog design, these are the tools. In physical design, these are the tools. I have given only few tools here. And all these tools are very, very expensive, I'm telling you. Extremely, only companies can afford. Or training institutions like us can afford because they are giving at a low cost for us. They can't give to all institutions unless they know that these people do not misuse it. You understand? So that is what is going to happen. Yes, when you are going from 0 to 1, there are 3 types of power consumption that are going to happen. When you are in 0, some leakage can be there, leakage current can be there, that is called leakage current. When you are in 1, high state, low state, in both the states they are called static states, there can be some leakage current. You are moving from 0 to 1, that is called transition current. 1 to 0, transition current. It is like this. If I am remaining like this statically, do you think that no energy is consumed? Some energy is getting consumed because some activity is happening. In a similar way, in the device, some activity will be there, some leakages also can be there. In 0 state, I will have some leakage. 1 state also, I will have some leakage. And when I am sitting, standing and sitting, my energy consumption will be more. Am I right? And when I am sitting and getting up, again energy consumption. So from 0 to 1, consumption of power is different. 1 to 0, consumption of power is different. So when I am giving a signal, signal is going from 0 to 1, 1 to 0, 1 to 0, like that, waveforms are changing. Power is getting consumed. One is called dynamic power, another is called static power. So in the device, you estimate static power and dynamic power, right? When data is changing. And again, one day I am moving the data from one place to another place. It is going through a resistive path. Though I am using copper metal or gold metal or whatever metal it is going to have finite resistance. If it is having finite resistance, it is going to have I squared R losses. I squared R losses means resistance. I square, some current is flowing. That square into resistance is the power that is consumed there. You understand? So when current goes through a bulb, how light is coming? That is offering some resistance. And when it is going through that, it is taking some energy. Some electrons, atoms are going from low energy state to higher energy state. From there again they are falling back. Then the light is getting emitted. Yes, sir. So if this light is falling in the visible region, you are getting the light. If it is not falling in the visible region, you will get heat there. So either it emits light or heat. So when I have billions of transistors in my chip, that too in a small finger nail size, billions of transistors are changing their state, the power density will be very, very high. Means so many transistors are changing state, so a lot of heat is going to be generated. So with that, temperature shoots up. If you really calculate it, it may go even to the temperature of a sun. Means on sun, how many degrees centigrade is there? So if it is not properly managed, the chip will burn away. You understand? So that's the reason why you have to use those devices which consume extremely less energy, extremely less heat. And also whatever heat is generated, there should be a package which will disseminate that heat to outside. Yes or no? Say for example, I put coffee in this cup. Heat removal will be slow. Yes or no? If I put in a copper vessel, so it radiates heat much faster. So I have to put my chip in such a way that whatever heat that is generated is propagated out to, that's why inside the processor, on a PCB, there is a fan also going to be kept. Some materials are going to be used such that who will have high conductivity and spread the message to, say heat to. That's why when you are talking long time on your mobile phone, what happens? Are you not sensing that heat? Yes, sir. So heat design is also extremely important. How much heat that it dissipates and how that heat is removed is also very, very important. Have I answered your question? Carbon, but carbon has a high resistance, is an insulator. Semiconductor has much less resistance than carbon. Graphene. And say in which way you are going to use it, that depends. Okay. What is next? So if I cover like that, how much time actually you are planning for me? So how much time is over as of now? Huh? 7, huh? Oh my goodness. So I have to cover it very fast, so otherwise, or I should skip something. So this is, I will drop this. This is VLSI design flow front end. I told you a front end design engineer, logic design engineer, how he is going to design. So I'm going to skip many things because time, how much, how long I can. 7:15. Oh, then I have to go like supersonic speed. Huh? So this is all flow given for VLSI front-end design, digital VLSI front-end design. I'm not going to talk about the steps there. This is all going to talk about VLSI back-end design. So if one becomes a VLSI back-end design engineer, he will spend all his time, lifetime in this flow. And in this also, designer is there, verification engineer is also there. Physical design, physical verification. Sometimes there are engineers only to close the timing. Only these steps they take care. Some people take care of floor planning, placement and other things. Some people take care of clock tree synthesis and other things. Some people take care of routing. Or 2 or 3 steps also they can take care. Or all the steps depending on the company in which he has joined. So this is standard cell design, I am not going to cover. This is analog design, this also I am not going to cover. So you remember that there are different types of designs and each has its own design flow, and a person who joins in one design flow will not change his career again into, but it is not a hard and fast rule, because when you become vice president or director or some such thing, though you are a physical design engineer, you have to take care of what other groups, because you will get that type of understanding and what others are going to do, how you have to handle it. But generally, lower level understanding will be perfect only in one field. Okay. So this is all about VLSI. Only second step we have covered. What is VLSI? Right. So this is what global semiconductor market is going to be. Over the past 3 decades, semiconductor industry has experienced rapid growth, delivered enormous economic impact. So in 90s, it was the era of PCs. In 2000, web and online services. In 2010, smartphone revolution. So now 2030, AI alone is projected to contribute more than 15 trillion US dollars to the global economy. Just imagine AI impact on semiconductor design, or without semiconductor design, you can't achieve your AI goals. You may be thinking that I know many AI algorithms. Unless there is a real harsh which will drive that, you can't design that. Yes or no? So now AI chips are going to be different. Their speeds are different. Their functionalities are different. That all that, if it has to happen, semiconductor industry also has to go at a much rapid rate. Semiconductors have become essential to our modern world, which is why long-term market demand for semiconductor remains stronger and stronger. Okay, so I'm going quickly, just stop me wherever you want me to. This is the revenues that the semiconductor industry is producing. Today, if you see, it is around 540 billion US dollars. 540 billion US dollars. It is likely to reach 620 US dollars in 2024. So total estimates have not come, but it is going to cost 600 billion US dollars, right? So how this income is coming, you can just see. So these are different markets. This is communications, 169 billion US dollars semiconductors, 140 in computers 140 billion, automotive, consumer, industrial, government, all these, this is how the revenue is going to come for the semiconductor industry. So this is what does this convey? What is the percentage in total? So which is having highest? Communication, computing, automotive. These are the 3 areas where lot of semiconductors are widely used. You understand? So other things like industrial, consumer, they are all small players when compared to those things. Now you understand where VLSI chips are coming, where they are going to be used maximum. And in days to come, you are going to have more and more communication requirements. Today you are working at 5G, you want 6G. Yes or no? Right? Now, whatever laptop you are using, you are already thinking that it is like a bullock cart. Am I right? You want to work with a laptop which is going to work at much higher speed and much thinner. Yes, especially in last year, 2023, there is a negative one. The sales of computers have come down. Okay, so this has shown, only one has shown positive, that is automotive industry. In all other domains, because of the various factors, I will tell you later. So today, if you see global semiconductors market, this is 2021 was at 590. From 590, it has come down in 2023, again going up in 2024, and it is likely to reach this 600 billion. This is 590 in 2021, is now around 640 or 620. Then it is going to reach, all people are predicting that by 2030 it will become $1 trillion industry. How much? $1 trillion industry. Which are going to grow? See, this is going to grow from 225 to 350. So what are all these three things? Computing, wireless, automobile. You can call this CCA. Computing, communication, automobile. They are going to generate 70% of revenues for semiconductor industry. All the remaining are going to generate 30%. So this is 70% of growth predicted to be given by three verticals: automotive, communications, computing, and data storage. Right? So next is what? So that is what I have shown. That those three alone are contributing 70%. So this global market share, so how country-wise it is getting generated. So highest is going to whom? US market. Next is South Korea. Next is Europe. Next is Japan, Taiwan, China. This is how. Where is India in this? Are we generating anything? No innovation in India. Nothing is there. Though we are all saying that so many engineers are getting trained. Where are they going? They are all going to different countries and working for different companies. Not that there is no talent, but there are no companies which can generate revenue. They are all generating in the design side, but that is not much when compared to these figures. In billions of US dollars, what is this? What we are generating in design is much smaller.
So this is based on the company headquarters. Which country the company belongs to. That is
if all our students are going to US, that means our income is shown there, not here.
Okay, even the companies which are here, they are working, they are for the US.
Yes. Yeah. So though you are working hard, the money is shown there, right? Okay. So this shows how they are able to generate. If you see that much of revenues, the more R&D. For example, America spends between, what is this one? Biotechnology.
Pharmaceuticals.
Pharmaceuticals. 23% it will spending on R&D. And the semiconductors, out of its revenues, 19.5 only it is spending. Then it comes to this, maximum revenues wherever government is spending, there the revenues are increasing. If your R&D expenditure from government is more in that sector, you are able to get. So with 19.5, they are able to rule 50% of the world market. Is it not worth it? You understand? With 19.5% or 20% of revenues coming in semiconductors, they are able to capture 50% of the world market. Okay? The other people are spending less. How much we are spending? That is what Indian government is realizing. We have ignored this industry. We were all thinking that software. But this is also very, very important. Right? So again, if you see, this is between the sectors in US, how they are spending. Between countries, if you see, US is spending 20% out of its revenues, Europe is spending 14%, Japan 12%, others like that. If you see,
So
whoever is spending more money
12% of its entire revenue.
Right. Semiconductor revenue.
Semiconductor.
Out of semiconductor revenue, they are giving back to that industry by spending 20% on R&D.
Okay.
Since they are spending 20% on R&D, their innovation is going up. That's why they are able to dictate to the world their products are superior or better or whatever it is. Their fabs are growing more and all that. So even in that way, if you see Europe, Japan, Taiwan, South Korea, China one is not given here. China is somewhere here, right? Global share.
So Taiwan is above
South Korea. Taiwan is TSMC. Yeah. TSMC. See, that story, if I have to take, it will take some more time. So that is called, that is a fab third party. Means earlier you take Intel or IBM, they are all verticals where all things are done in the same company. Starting from design to fabrication, everything is done within the company. That is not a strong, good revenue model. So now, what this Samsung, not Samsung, what Apple or AMD or NVIDIA are doing, they don't want the fab. They make the design the chips, give it to Taiwan, they make the chips, and so they are fabless companies. Earlier, fabrication, design, everything was integrated into one, and that is not a perfect economic model, because you are using your facilities only for your purpose, not for others. So the cost will go up. Now with third party fabs coming, everybody, the fab is no longer available. See, all slots are booked. Say for example, you use your own car for your own purpose, or you use, what is this car? Uber.
Uber.
Which is cheaper?
Uber.
Which is economical?
Uber.
Yes. So that is what is going to happen. Countries are raising. NVIDIA,
so Taiwan, why it is leading? Because it's the availability of fab and then semiconductor.
Right? Because of that fab, they started investing on fab much earlier than all of us. Right? They are spending more money on fab than even America. That's the reason why Taiwan has a bigger share in the market. Though it's a small country, they're focused on it.
Yeah, I'm very surprised to see that.
Yes. So I think this one slide I have to show. What are all going to be? Say, people working on specification side become marketing and technical teams. Architectural design architects. They grow and finally become that. Functional design engineers are called system design verification engineers. Logic design, logic verification, implementation engineers. Analog engineers. Like that, various positions are going to be there in lot of positions. Oh, acha. Okay. Thank you, sir, for you have raised some questions. We can discuss later, private. So coming to India's VLSI ecosystem. So now India is thinking that we should do something. We should also come into this map, right? So this is where Semicon India has come into existence recently. So if you see today, top producers are who? Taiwan comes on the top, South Korea, US, China. Top consumers are who? China, USA. You may ask me, sir, India has so much of population, how is it we are not figuring? We are using so many smartphones. We are all purchasing from them. Semiconductor consumption is happening where? They make the instruments. They purchase the ICs. They make the products. And those products we are not coming directly into that. You understand? Though our usage is very, very high globally, with 1/6 the population being in India and the maximum usage of cell phones being in India, we are nowhere in this. Because we all purchase whose phones? Either US phones or China phones. Am I right? Things like that. So that's the reason why India is also assembling and trying to get what is required. Why is the semiconductor industry important for India? To meet the demand and reduce, we are importing lot of things. Our dollars are getting spent more on imports than exports. So that is why one thing. Advanced AI, IoT, 6G and smart tech, all these require that we should have our own AI, chips. Tarvata, achieve technological leadership. Now we are depending on others, our military applications, so many things. We have to purchase everything from other countries. We are not able, see, your secrets will, so what they are giving, you do not know. You have to take. Right. So strengthen digital security, because security aspects are very, very, whatever instrument that you purchase, what is going to happen inside, though you analyze, you may not know. Global hub for electronics design, we want to become ESDM, electronic design and manufacturing, ESDM, electronic system design, and so that is what India wants. So now the fabs that have come, so this is what India is now. India is committed to become the world's reliable partner in global supply chain. When we understood this? During Corona period. See, if a chip is made, it has to cross the boundaries either 50 or 60 times, because it has to go, travel. Wafer is produced in one place, design is done some other place, fabrication is done some other place. It has to cross the country's borders many a times. And during that time, we felt that there is supply chain problem, and that's why many companies could not even sell their cars, because a small component is not there available. Everything they have, but they don't have the IC. So that's why. So India is committed to becoming the world's reliable partner in global supply chains. This is the best time to invest in India. India is making policies keeping in mind goals for next 25 years, because if somebody spends billions of dollars, if that industry cannot continue for another 25 or 30 years, what will happen? Just imagine, because technology itself is changing for every two years. Whatever money that you have to spend, you have to recover it at least. So something has to be done like this. We'll work with stakeholders to understand what this is, what Modi's statements are. Say today, now most of the fabs are going where? Gujarat, right? One fab is coming into Assam. So these are the three places where this billions of dollars of investment is going to happen. So why people should come and start their companies? Advantage India, fastest growing G20 economy. Our GDP is growing, our say revenues are going up, highest fintech adoption. In India, if you take any financial transaction, even a common man is able to do it. Highest, then second in internet usage. Vibrant startup ecosystem. Because of this, India is well suited for this industry too. Fifth largest economy, 7% GDP, now it has come to 6% now, or 5.6. Then 522 million working population with a median age of 28 years. 520 million. Half of the population is nearly 40% of the population. Third largest economy it is going to become. So, third largest ecosystem. There are 1,16,000 startups in India. 1,16,000. 27,000 are technology startups among them. 3,000 are deep technology. Means people like you or people who are going to work in VLSI, etc. 24 billion equity investment is being received in India for these startups. How much? So that is what it is. 112 unicorns are there. Unicorns are big companies, right? 100 million or 1 billion. 1 billion. So 10 million STEM graduates pipeline is there. Engineering graduates coming out 10 million. 10 million means 1 lakh engineering students, not 1 lakh, sorry, 1 crore. Yes or no? 1 crore, 10 to the power of 6 plus 10. So 1 crore engineers are coming as engineering graduates now. You have to find, this industry cannot absorb, only some can get into. So these are all the companies working in India. Intel, Qualcomm, AMD, NXP, Micron, Broadcom, Texas, NVIDIA, these are all the companies working, operating both in Hyderabad and Bangalore, and they are going to spread to other states also. And EDA companies are Cadence, Synopsys, Mentor, and ARM. These are the companies.
You can see that all these companies have their headquarters in Hyderabad.
Not headquarters. I may say that
those.
India headquarters.
India, yeah, in India headquarters. In
Global headquarters are elsewhere. That's why even though we are all generating money, this is accounted where? Yeah. Actual expenditure is salaries only. They show salary expenditure. Suppose they get $1,000. $300 are going to salaries. $700 will go as revenue there. And for us, only this $300 is shown. So these are equipment and tools. For these fabs to be, for making the fabs, you need equipment. Na? They are not ordinary equipment. They are precise working is required. There are only very few companies, only 3 companies, Applied Materials, Lam, and KLJ. This is where US is controlling. If they want to go to advanced nodes, China, it stopped by controlling these 3 companies. You understand? If you do business with China, we are going to do something, sanctions and other things. So that is, it is a very globally, it is a highly controlled market. No? So if they don't supply, we will not survive. Those fabs also will not survive. So strategic facilities. So these are the companies, and then these are all fab consumables, people who produce. So these are all not electronic, but we are not talking about them. We are talking only these companies. Is there any fab in this? Nothing. Only these are all. That is India's virtual fab ecosystem, we call. Design bar virtual fab. So in India, we have power-wise, if you see, 422 gigawatts, third largest India. Then installed capacity 179 non-fossil fuels, then renewable energy. So we have enough power generation in the country. And the same way, talent pool, 10 million STEM engineers are coming out. Semiconductor talent development by 26 will be 85K, means around 1 lakh engineers are likely to be there. By what time? So out of this, Veda has generated around 5,000 engineers. You can imagine where we are out of 1 lakh or 85,000. So small percentage, right? So 5%. So 28.2 median age. This is okay. This is a domestic market. Electronics production by 2026 is expected to go to 300 billion. Not semiconductor, electronic equipment. So what I told 600 billion and 1 trillion is about semiconductors. So 110 billion semiconductor market. In this electronics, 300 billion, about 110 maybe, 1/3 maybe from semiconductors. Second largest manufacturer today, second largest manufacturer of mobile handsets. Even then, why we are not figuring? We are importing all those chips. We are not making the chips. So that's why we are not figuring in the semiconductor. So to encourage this industry, what government is doing? PLI scheme, production linked incentives they have given. Government has put lot of money, several billions of dollars, 22 billions of dollars. It has spent on all these companies under product to linked incentive scheme. So mobile phone, suppose you are producing more and more mobile phones, they are getting incentives because at least some dollars they are saving. So that's the reason why. Though mobile sets they are making, importing and exporting mobiles, then compared to exports, imports are more. So that's why real advantage is not coming. But in spite of it, that ecosystem is getting developed. So this is specs. What is specs? Scheme for promotion of manufacturing of electronic components and semiconductors. No. So to this specs, the actually modalities are evolving. They want to support semiconductor grade chemicals and gases, capital goods, and for semiconductor manufacturing, engineering, R&D. This they want to spend under 25% capex. They want to support 25% capex under that. So now, what is really happening is, Semicon India, after Semicon India has come, this has decided to put 10 billion outlay last year, 10 billion outlay. Now it is going to 15 billion. You understand? So as incentives, Government of India is giving, if anybody is starting fab company, 50% of the fab company's cost India is bearing, 25%, 20 to 25% the state government is bearing, another 20 to 30% only, 25 to 30% only. If you want to start a fab, 3/4 are coming free for you from Indian government and the state. How much encouragement they are giving, you see, right? But that I will tell you. So, so this is what. So this is called a pari pasu, means 50% government, central government bears, another 25% or 20% state government. The applicant is spending only the remaining part. Okay. So what are the target? So which companies? If you are fab or display, MP or OSAT, I said, what is this? Assembly, testing, marking, and means after the chip is made, it is taken to an assembly, verified whether it is working properly or not, and then it is packaged. So those companies. Compound semiconductors fab, then MEMS fab, sensors fab, display devices fab. The sensors, etc., are going to be used widely for IoT applications, right? So today also, Modi has given a statement that we want to spend a lot of money for LCD, LED display sales. Semiconductors are going to be widely used. They want to use because imports are increasing. So now, if you see what are the fabs, these are the 4 areas, 4 or 5 companies where maximum money has gone. One is Tata and Power Semiconductor Manufacturing Company of Taiwan. PSMC is from, so they joined. Indian Tata company and PSMC joined together. They are starting with 11 billion. 11 billion means 91,000 crores. So out of this, how much they would have received from government? 45,000 crores. Another 22,000 from state government. So these people are going to spend 30,000 crores or so. That is how this investment is going to. So what they are going to do? 50,000 wafers per month, per capacity, wafer supply per month. 50,000 wafer supply per month. At what nodes? I told you, technologies. Which technologies? 28, 45, 55, 90 and 100 nanometers I told you, na? 110 nanometers. So we are taking fabs only up to 20. It is up to them what they will start. Whereas globally, where we are, 2 nanometers and 1 nanometer. So how much time to go to those advanced technologies it will take, you can imagine. So now you are able to appreciate this, where we are spending money. So this is a Micron. They are also starting a company in Gujarat. These are called what? OSAT companies. So outsourced assembly and testing. So how many? $2.7 billion. So many dies they are going to bring out. Like that you are seeing. So here I have not mentioned one company which you have mentioned today. That I will show you in the next slide. So that is Kaynes Semicon.
So Keynes, today, as I mentioned earlier, that is Keynes, the team was there with our Chief Minister on setting up a 20 crore academy for skilling from Kerala.
And then they also gave the CMA letter of intent that they would like to start in Kerala.
Education point.
Education.
So if you see, actually everything is going to Gujarat, 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 one going to Assam. So many billions of dollars the Indian government is spending, and this Gujarat is going to become India's Silicon Valley. Earlier people used to say that Hyderabad becomes Silicon Valley or Bangalore becomes. Now you can see what exactly is happening.
Because the India.
So let me skip this because it will take a lot of time to explain all that. I think already I have. Okay, sir, I'm going in the reverse way now. So what Micron is doing, so 2022 scheme is announced. June, they have come and Micron's announcement has been done. Then groundbreaking was done in September 23. Construction is in full swing in May. That is what 5 months advance pricing agreement negotiated already. Okay. So government is also entering into MOU on building supply chain resilience and innovation. What is the supply chain resilience? If you make something, unless you get, suppose you have made VOSAT or ATMP, people who are making those chips should send those chips to you to test it. Yes or no? Otherwise you will not succeed. So in that supply chain where you are going to be, how you are making negotiations and arrangement to see that your fabs also survive. MOU with IBM and MOU with Purdue University to see that the missing links are provided. Semiconductor supply chain partnership with America also is done. MOU on semiconductor supply chain partnerships under framework of Trade and Technology Council. These are all things that the government is doing. And recent announcements are this. Applied Materials have agreed to put 400 million for setting up collaborative engineering center in India. Where these are going to come, we have to see. AMD has agreed to put 400 billion for R&D. That is both in Hyderabad and Bangalore. Then Microchip is spending 300 million in expanding its R&D center, and LAM is also going to put 60k million for this purpose. I will also skip this. More or less, I have covered these points. So, what are different programs? How the benefits are going to come to companies and all
so
that.
92% Taiwan leads.
Yes.
In advance.
Semiconductor production. Semiconductor production, not in design. Not in design. So this is one small area. Okay. So through these investments, this Make in India has to become successful. Okay. So who are all supporting this cause? I have put it there. So last one is challenges and solutions. So here the cost of the fabs are extremely high. Then it requires consistent high quality water, electricity, and that is what you are asking, right? So these fabs require very high quality power because any high clean rooms also are required. So for that continuous water supply, power supply, and without fluctuations you require. Then fabrication units take up 5 years for full production. Gestation period is very high. Key materials like silicon, germanium are to be imported. Just it is not enough you have a fab, you have to import all these materials. US-China tensions are going to put some more sanctions on you or some advantage for you. You have to manage this global politics. It is not enough if you start it. You have to win over in the global politics to see that your fabs will survive. And India lacks highly skilled labor and advanced technology to support these fabs. That means skilled manpower also we need to. So these are challenges that are going to be there. Actually, I have given some more also. So that slide has given a few. huge cost, production process is complex, strict environmental control, highly resource intensive, consuming up to 5 million gallons of ultra pure water daily, efficient access to power, highly skilled talent and labor, supplier ecosystem. So this how you have to provide solutions. I have put something, they may not be unique solutions, but according to my idea I have put long-term policy stability is also required from government, raw material availability is required, specialized equipment is required, continuous optimization of production quality, yield, throughput is essential, then eliminating errors and waste control is also important, otherwise sustainability becomes a big problem, safeguarding intellectual property right against evolving threats. That means build a comprehensive long-term cyber resilience strategy supported by trusted experts and partners to ensure security at all stages. That is where I am telling, if you are not just technically competent, it is not enough. You have to be ethically, otherwise all that money that we have put, if you are acting in a different way, transferring the knowledge to others, what will happen to the country? Just imagine, it is common man's, taxpayers' money you are going to misuse, right? So, so with this, I think this also I will cover in 1 minute and complete it. There are, I think it will take some time. So semiconductor technology also has some challenges. See, the 5 walls of semiconductor technology, people say. One is called scaling wall. You cannot go on reducing the size of the transistor because there is some limitation for that. You are going to atomic dimensions. Memory wall means when processor is communicating with memory and getting data, this time is becoming, number of flops, floating point operations are coming down. So new technologies are required. You require elements which can have both memory as well as processing power. That is where neuromorphic technology or quantum computing, these are all going to come into play. So this memory wall also should be broken. Then power wall means if you increase the density, number of devices in a small area, power density will increase. I said that it will reach the sun's temperature unless you know the techniques to manage it. Then sustainability wall, because ecosystem also has to be sustainable. You go on producing something, all this electronic waste is going to, it should not become a dump yard for electronic waste. Or the cost wall means you should do all these things without increasing the cost. You understand? So these are the important 5 walls which the semiconductor industry is going to face, and for this I also have given tearing down the walls with the new architectures, means Van Neumann architecture for computer will no longer work. That is where I am saying this is brain inspired computing, people call brain, the way that neurons are working in the brain. So much of parallel processing is happening. So in neuromorphic computing, people try to design a cell which will communicate like a neuron and work on a different technology altogether. So you need to have, demand for scaling traditional Van Neumann computer architecture will not work. People have to do a lot of R&D to see that the other thing happens. In a similar way, with fundamental changes, the architectures, basic structures of transistors, even the structure of transistor also should undergo a change. So not in the conventional way. I am not going to discuss in detail, tearing down the walls. See, then more than this, when you are fabricating something, you use what is known as a photography. This is called lithography. What is it called? Lithography. You see, finally there are different layers, and every layer has a mask. You are supposed to reproduce that mask on the wafer, and then it is made, right? So when you are making that, how you are making those images? Say for example, I am taking your photograph with the light. What is the wavelength of light? Let us say 3000 angstroms to 7000 angstroms, or 300 nanometers to 700 nanometers. With 300 nanometers, what type of resolution I will get? Not less than 300 nanometers, right? My chip is working at what nanometers? 1, 2, 5 nanometers. Whereas my light is at, so I am able to see your face clearly because my wavelength with the light, whatever I am seeing, is reflecting all parts of your body. But if my wavelength itself is very high and I am taking the image of something, what clarity I do get on that? What you see is not what you get there. So that is a big challenge. That's why people are going not 300 nanometers, less than 300, ultraviolet, huh? Extreme low ultraviolet, EUV people call it. So even with EUV, this is going to become a big challenge, problem. So that's why what is it? Okay. So this is what I said, tearing down the walls with EUV, extreme ultraviolet, high numerical aperture EUV, high NA EUV, because you are not able to go less than EUV because there are some other problems with that. So you are trying to increase the numerical aperture and get better pictures with bigger lenses. So even that bigger lens also is going to become a problem. How big you can make, So that is, lithography is going to be an extreme limiting factor. Though you are able to make transistors of low size, to reproduce them on a chip is going to be a big issue. So that is also limiting. So then what is this? With better device map. So you are using MOSFETs, then you have gone to FinFETs. Now you are going to, even FinFET is not working so efficiently. All gate, GAA transistor, people call gate all around transistor. So like that. So future is going to be complementary metal oxide transistor. So like that, we are I am pressing a wrong button always. So this is an important slide which you can see. So N7 means what? 2018 7 nanometer. N means in 2018 our technology is 7 nanometer. 2020 5 nanometer. 2022 3 nanometer. What is the latest technology that people are using in 2024? 2 nanometer. 2 nanometer means how much? 50,000 transistors in the diameter of a human hair. Next technology is going to become what by 2030? After N2, A14 means what? 14 angstroms. 14, that means 1.4 nanometer. By which time? 2026. This is not going at a fast rate. By 2026, 1 nanometer. By 2030, 0.7 nanometer. I told you, it will become half, I told you. 2 nanometers has become 1 nanometer. 1 nanometer is becoming 0.5 nanometer. 0.5 is becoming 0.2 nanometers. That is how. What are the devices? Up to these 2, 3 nanometers FinFET people are able to use device. Now gate all around and nano sheet transistors are going to be used in these technologies. If you want to go to 0.5 nanometer, this is called CFET, complementary FET. Means so far PMOS and MOS are coming side by side, one over the other to reduce the area. That is how it is going to be made. So the way how the transistor is going to look like also I have given. And context aware interconnect, based on the size of the transistor, interconnect also should become smaller and smaller. Okay, so I think with this I will stop. There are some more slides, but VLSI and emerging technologies. You want me to cover or stop it here? I think already we are not 740, 820. No, 740. You have to understand what is happening. What is the time now? Oh, I see. It is going in the reverse direction, 740. Correct. So why is it you are putting the reverse way? So what is the code there? Oh, dare to challenge the status. Okay. Right. Got it. Say that clockwise is this way. Clockwise can also be this way. Great, great, great. Okay. So now, shall I go further or stop? Huh? Okay. Just so only one slide. So these are the emerging technologies which are going to rule. What is that? 6G and Wi-Fi 7, mixed reality and virtual reality, computing at the edge, and self-driving automobiles. Edge means not only they collect the data, the processing also going to be incorporated. In all IoT devices, now what's going to be edge computing you are putting. So that is what it is. Computing at the edge and the self-driving automobiles, because self-driven cars and all that. Holography and avatars means, what is this holography and avatars means? So suppose I am talking now, you are only seeing my image. Tomorrow, if I am talking from Hyderabad, if this technology comes into play, Crosser will be talking like this in 3 dimensions. Still I am in Hyderabad. My avatar will be here. You understand? So that type of conferencing will be there. Probably I can also make dosa and give it, coffee and make give it, because my avatar is here. That fellow can make whatever they want and supply it to me. All right? So that is going to be the future. It is a robot, another type of robot. What is that? Fiber optics to now all communications, wired communications will change to fiber optic, and everything. Power management is going to be, the normal ICs are going to be a big challenge. This task requires devices like silicon carbide, gallium nitride that are only available in small size wafers, and the engineering to take them up to 300 nanometer wafers. Means, though we have these devices, these are not available on 300 nanometers. So that means a lot of research is required for handling that. Biotechnology, multiple demonstration of implanting devices in humans and contactless sensing require optimization. So means lot of devices are going to enter into your body, and contactless also, because health is one important thing where people are spending money like left and right. They may not spend money for other things, but for health they definitely. And quantum devices are also going to be there. This is what 2021 IRDS proposal. What is IRDS is, you know IEEE. IEEE has a lot of verticals. They all have come together and prepared this, not given by one person. A lot of engineers worldwide have come together and said more or less whatever I have shown there. It is very difficult to read here, but I have already shown them there. So if these new technologies come, what is going to happen? What? Next level of process automation, visualization, virtualization. 50% of today's work activities will be automated. 50% of the work activities that you are doing will get, with these new technologies, automated. That means your jobs are going to go away? No. You have to work in a different way. Huh? So not routine things. Connectivity. Up to 80% of global population are going to be connected by 5G. 80% of not Indian population, global population. That's why you are going to 6G. Then 75% of distributed infrastructure, enterprise generated data will be processed by edge or cloud computing. Now data processing is centralized. Now that, if that happens, edge computing comes, it gets distributed. Then next generation computing, people are going to spend 1 trillion value potential for quantum computing using use cases at full scale by 2035. Quantum computing is going to come to the main field. No longer 0, 1, qubits you are going to call. So quantum mechanical principles, superposition theorem, Pauli's exclusion principle, quantum mechanical effect, all these things you have to understand to design a computer. You understand? So that is what is going to happen. Applied AI, 70% of all digital service touch points, voice assistants will see improved usability, enriched personalization, increased conversion. This is what is going to happen finally. So future programming, reduction 30%, 30x, reduction in the working time required for software development analytics. Whatever you are spending time to develop software analytics, it will be reduced by is 30x times, 30 times more. So that is how software is going to get developed. You understand? Trust architecture means approximately 10% of global GDP could be associated with blockchain by 2027, because so conventional lot of cyber crimes are happening. So if you go for blockchain technologies, so people expect that crimes can be reduced. So bio revolution 45x, next generation material 10x, future technologies greater than 75%. This is how the impact is going to be there. What is this? This is according to McKinsey, what is going to happen. Let me not worry about all these things. More or less those points I have covered. Completed.
Okay.
So these are all the points which he asked me to cover.
So I just want to tell you that a few days before I just asked him, can you cover all these points? Then all these slides he customized and prepared for this session. Okay, we cannot find all these information grabbed together at one place. And
no VLS engineer can, even if you ask them, even if they are working in companies, they know about their field. I told you already. One small area they know, but not the whole.
so understanding this in an abstract view is something that we want, because how many of you are here for the Fireboard 80 for the first time? Okay. Okay, this is the 122nd edition. So we started in 2013. Every month, first Wednesdays, it used to happen. So we want to bring in what technology that we have to focus on the future. For example, blockchain and all those things we talked in 2016, 15. At that time, Bitcoin price was very cheap. So we talked about Angular or all those things in 2013. Okay, JavaScript, all those JavaScript frameworks and all those things, or front-end automation, Jenkins and all those things. So as of today, we just understood that VLSI is going to be very important, and we want someone to speak about that. And then we found that he would be the best person to take that session. And thank you so much for putting all those effort to prepare this. Coming down from Hyderabad, and at tomorrow morning 4 a.m. he has to go back. And Dr. Jaishankar Prasad was here. He was the one who actually created the Kerala Startup Mission, IC4s and all those things. He actually had to leave earlier. But he put a status that he is coming to Kerala. Then there was a meeting that was happening at the CM office, but I earlier mentioned that Keynes coming there, and Usha Titus madam contacted him and Jaishankar sir and asked that can we have a meeting. Then today afternoon we had a meeting, and also the CMIT fellow Vishnu was also there to see that how actually we can increase the awareness about VLSI, and that what our students have to prepare, because we do not have a proper curriculum here, or we do not know how to prepare our kids for that, and that Veda has been doing it for past 27 years. And their alumni network itself would be a great value addition for if you bring them as a community to access. So what was trying to do is like with Mueller, like that is how we can work together and then democratize the access to, because here it is very hard for us to think about what is a proof of work, because a lot of softwares that these people have to do to design, which might be proprietary, and how actually we have to do. So actually Akshay is there, we are working on thinking on how we actually help the students understand and take a path towards VLSI design and a career towards getting into the core companies, right? So that was the whole reason why we just thought like he has to be here. And thank you so much, sir.
At least 1% has it gone into, will it be registered in your mind? More? Thank you. So, finally, how much is useful for you is the point, not how much I have covered.
And we can officially close the session, and then we will have offline discussion. Actually, normally after Fireport it is a discussion. So we have Raju Kumaraswamy there. Is like actually that is once we start the discussion, it may go up to morning 5. It doesn't. You don't worry. We will. No, yeah. And then we had Barker there, Bhagav Bhaskar, who actually worked on.
I can even stay here up to 1 o'clock also.
Yeah. And then I also want to introduce Ruby. So how many of you know Arduino boards? Do you know that Arduino has, where does it get manufactured? You know? Italy. Okay, and it is an open source framework, and they have started its Indian operation, and she heads India and SE on its sales. So she is here in Kerala just because he is here, and then based on that, she has arranged her visit to Kerala. So she is here for 5 days, and I think she has been meeting with different government departments, startup mission, kites, to schools and all those things, because Arduino board that is being used by everyone. But as an open source thing, what happened is like everyone actually start downloading and building this thing and having the Arduino label there, the original logo, and selling it. And what happened is the reliability of that brand is getting impacted, and so they just want to start manufacturing in India. They started at Mysore, and she just came here to understand the Kerala ecosystem, and just 2 seconds.
Okay, yeah. Hi everyone. So I'm coming from Delhi. So I'm Delhi based only and here for 5 days to explore the opportunities. How can we collaborate? So as all of you know already, Deepu introduced that you know that Arduino is Italian company, but it's a global brand and everyone are using. So now all the products will be made in India and for India because the biggest issue what we were having is the cost, right? Because of which all started shifting to the clone one. Now people are not even aware that whether we are using the clone or we are using the original because 99% market is of clone only. So there are very rare people who are using the original one. That's why like the starting point from where we started using Arduino, we are using clone one. So we are not even able to differentiate. So being Arduino, so when we realize that this is the what it is going on here and India is the second largest user of Arduino. So this is why Arduino has entered in directly in India and we have established the manufacturing unit and now all the products like we are starting manufacturing with Arduino Uno R4. So Arduino Uno you must be knowing. So there are different families of board. So Arduino Uno R4 Ek we have given the name and launch will be in February and eventually we'll manufacture all other products of Arduino as well which will be for India and made in India like this. And one more thing I just wanted to introduce that just for your awareness that Arduino is more famous for this non-guided boards, microcontroller boards. But apart from this, Arduino is also having the guided projects along with the whole curriculum and the access to the Arduino cloud and all. So I would be happy if you go and explore in the website and get aware about the Arduino more. Thank you.
And then I also want to introduce one more person here. So Barker, he worked on Porter Player and he was in Apple. He worked on iPod as well as on Apple Watch. Okay, and he's working on one product very. So he will be taking a session on February. So I just want to introduce our upcoming speaker. Yeah.
So what should I say? So I manage the iPod video team and Apple Watch biomedical team, the first generation. After that, 2014, I came back to India. Now I have a startup which works in unmanned systems. So I'll be taking a session in February 4th. Unmanned systems. Basically, unmanned boats. We make unmanned ship software. So I was with joined Podapair in 2000. I studied at IIC and then I came out. Venkat Raipudi interviewed me in Bangalore Palace in 2000. And then I joined, I came to Hyderabad, was there 3 months, and then they hired me for the US office, so we have to go to Seattle. So I was with Podapair 2.5 years. So I went to from Podapair. Podapair had built the first chip for iPod. So they actually sent me to do the system bring up for first generation iPod. That's how the relation with Apple started. And after 2 years, I joined that. System bring up. The very first. Suman is in the hardware team, no? Hardware, yeah. Yeah, we call system bring up the chip comes and then we do the boot up thing.
Okay.
So that was my background.
Good. Thank you so much, and thank you so much for coming. And so he's like he normally doesn't go for public meetings and all those things. That he said it. But I just asked him that you have to come because Fireboard 80, that is, it was started in a aim that people of similar interest to come together each month, and each month we have one session, and then the people who are interested on that segment will come together. Then they form small communities, and then they start continue forward as a community, because seeing people of similar interest and passion, as well as people who have accomplished certain things, that gives us confidence to pursue one career. Many of the times we do not want to try anything new. We do not want to challenge the status quo because we see that people, whatever they are doing around us, and we just want to take that path along. Right? So what you have to understand is access to the right network and knowing the right, getting to the right skills is very important for you to live in this world, because today the world is of infinite leverage. Anything that you want, that is, you can see that the top billionaires across are first generation billionaires, right? Only thing that they have is access to the right network, right technology, and they started building things. From where did they started? Just like the garage, right? So anybody can do anything, but we are not dreaming high. That is, we always limit our dream. So Fireboard 80, that is, we started it just to help more people come forward and start trying things. And there will be, it is 11.5 years this time this year, and then next year June, like only 6 more editions is going to happen for Fireboard 80. So from the 12th year, that is, we will be shutting down the Fireboard 80, because what we plan to do is, like MuLearn that we have created, it should go to all the campuses, all the companies, because it cannot be something that can happen at one place once in a month. 12 years before when we started, it was okay, but you can see like every month new drops, every week new drops are coming from the giants, right? Lot of things, lot of discussion should happen, but it should be based on your interest group, and it has to be divided into different IGs, and based on that, people should come together and have discussion. So that is where the peer learning network of MuLearn happens, and as of today, around 40,000 people across the state are part of that community, and it is going to scale in the coming days. So these type of sessions, like there will be an application where you can have meetups and have small discussions, bringing together people of similar interest and having conversations and connecting to the people. Okay, thank you so much, and we can officially conclude the session. And normally Fireboard today, it is not just about listening to some people, it is also about networking. After that is where the conversation start, and building the right connects is very important. And I would like to bring in that Arjun AG, who is the committee, yeah, to hand over a small gift to, yeah, token of appreciation to Subbarangaiah sir.
You want to be formal?
Yeah. And just please join me so we can So this is something that I will be sending to JA. Okay. Thank you so much, sir. So he's working on unmanned systems. And so Jay previously told that he will be coming to KM, right? So we have